Hey everybody, I decided I'm going to take a look at this this Brown & Sharpe Digit Dial Plus model number 599-1003. This is a digital drop indicator, and it's in excellent condition even though it's older technology. Has the original AC adapter with it, some instructions that go with it. And what this is supposed to be able to do is it's supposed to be able to either work off of the AC adapter for power, or it has a NiCad battery internally that's supposed to charge so that you can actually take it off of the AC adapter and use it. Now, it's not working at all. If I attempt to power it up, nothing happens. Now, I verified that there is DC voltage coming out of the AC adapter, so I know the AC adapter is not the problem. So that would make you think, well, then this probably just it's broken and, you know, there's no point in going any further. However, it actually says in the instructions, it mentions how when you first get it brand new that you're supposed to give it a full 24-hour charge overnight before it will work correctly. Now, it doesn't say before it'll turn on, it just says before it'll work correctly. So I tried, and it also says that if you have had it in storage for a long time, you also have to give it a charge and go through a reset process before it will work correctly. So I decided to try and charge it overnight, and I still couldn't get it to do anything. But then I got to thinking, this thing's pretty old. I'm wondering whether or not the NiCad battery cell inside here is junk, and whether or not that's actually causing part of the problem. So the instructions basically say that by design, you're supposed to be able to run this off of the internal battery charged, and then as it runs down, you put this back on the charger, and you're supposed to be able to continue to use it, but it'll take longer for the battery to charge. Or you put it back on the charger, shut it off, and the battery will charge more quickly. But it also says that if the battery is allowed to go completely dead, that a system reset needs to be performed. And the system reset is just a matter of holding down the on button and the clear button simultaneously. So theoretically, if this thing was going to work, if I hold these two buttons down, it doesn't say how long to hold them down, it just says to hold them down. We can see still nothing's happening. So this could be junk, but I'm wondering whether or not, if the battery is in really, really poor condition, whether or not it could actually be acting as sort of a short and killing any power to the digital electronics in this thing. The other possibility is the battery may have leaked some chemical and damaged the internal circuitry, made a bad connection. And the only way to really find any of this out is to open it up and take a peek. So, very cool. This clear strip you see right over here is actually what appears to be a glass scale, not unlike what's used in the DROs. This little spring here, return spring. There's a reader head right there that moves back and forth across this glass. Now that glass, to the naked eye, it almost appears to be just clear glass, but I have a feeling that it actually has very, very tiny lines in it, like a scale on a DRO. Well, if it does, those lines are much finer than what I could see even with the magnifier I have on my magnifying lamp. This brown device right here is the NiCad battery pack. It actually has a plus on one side. I can tell just by looking at it that it appears to be a series of button cells put together, stacked together in series to form the battery pack. So this back that I took off here is clearly not apparently the way in to service this thing. So I think I'm going to take out these 3 screws right here on this edge and see if this whole head comes off. There appears to be a ribbon cable that goes up to the reader, so I'm going to have to be real careful that I don't damage that. Well, how about that? Look at that, the way that's designed. We've got a circuit board that stays behind with this part, and a circuit board here. And the way that these 2 circuit boards interface with each other is through these little, what are probably gold coated contacts that then touch this. Not unlike the way some multimeters or digital multimeters have their faces attached and interface with the board. Alright, so I know that when I measure the voltage on the AC adapter, AC to DC converter, I get 11 volts coming out of this. That converter actually says it's only a 9 volt, but I think because it's unloaded we measure 11. So what I'm curious about for starters is I just want to make sure that that connector is good. See, now I'm measuring 10.5, so it's being loaded down when it gets plugged in, which makes sense because it's probably trying to charge this NiCad cell. Now the NiCad cell sits right underneath here, and its connections actually lie between here and another point right here. So that's interesting. Unless I'm on the wrong points, there appears to be 0 volts across that NiCad. I think I'm going to undo these 3 screws so that I can verify that that connection to the battery pack is where I think it is. Yeah, there we go. Look at the corrosion. Now, what's stopping me from taking this all the way out is this delicate ribbon cable that goes down to the reed head. And unfortunately, that cable does not unplug. How do you like them apples? Alright. They put some sort of goop in here to mechanically fix the position of this, isolate it so that vibration in that over time can't damage this or loosen this connection. I don't want to damage this ribbon cable, so I'm going to unscrew these 2 screws because I believe that'll allow me to remove this reading sensor with the ribbon cable intact. I didn't want to undo these screws in case it was a critical alignment, but it occurs to me there's nothing to indicate that these screws screw into slotted holes or anything like that. So I don't think that this is going to really do anything adverse. Oh, you're kidding me, right? That ribbon cable continues over and goes somewhere else. To the other side, to the sensor on the other side. Can I just unscrew that on this side? No. Okay. That's a bad idea. Scratch that. By the way, what's in there is an LED. So the way this works is there's an LED that shines through a glass scale onto a sensor on the back side, which is where the other part of this ribbon cable is going over to the sensor. Now I need to try and get this back into where I had it. Oh, there's 2 LEDs. Interesting. Betcha the reason why there's 2 LEDs is so that the unit knows which way it's moving. So if it's moving in one direction, one LED sees a pulse before the other one, and so it knows to count up. And if it moves in the other direction, the opposite happens. So I don't know if I did a good job of explaining that, but essentially as that moves on its track, the light from the LED gets broken up by something we can't see on the scale that causes pulses of light to hit the sensor. Every pulse represents one division, depending on the resolution of this thing. Okay. But the unit also needs to know which direction this sensor is traveling on the scale, and that's why it needs 2 LEDs and 2 sensors. Okay, so we cannot take this off of here. We're just going to have to deal with it the way it is. So what I need to do now is I need to remove all of this, or a lot of this, silicone gel or sealant that seems to be encasing this electrical connection and bonding this to the board. Well, it wasn't easy, but I was able to remove this battery pack. Use my trusty WLC 100 Weller soldering iron with a very fine tip on it and some desoldering braid, and was able to get this out. There's only 3 connections that were soldered. It's a 2-sided board, so the solder work did a really good job of removing the solder. The problem was that they used what appears to be almost like a silicone adhesive to bond this to the board. I guess they wanted to give, the nearest reason I could think of is that they wanted to give this some shock resistance. The mass of this battery pack, if it was allowed to just be supported by the 3 solder points, over time might start to put strain on those solder connections, cause small cracks, and you'd end up with bad joints. So now that I get the pack out, a couple of things I'm curious about. I'm curious whether or not this pack is, if this pack is acting like a big short. Maybe I can actually get this thing to power up off of the adapter now with this out of circuit. Depending on how the circuit's designed, though, it might not respond well to not having this load that's expected in there. Then again, who knows? I'll probably take a chance and order one of these. So I'm going to have to figure out what the heck this is. Shouldn't be too hard. I can clearly see that there are multiple cells sandwiched in here together, but what I can do is I can actually take a blade and cut this off. First, I'm going to look for any numbers on here. It's clearly marked with a number 108. That's interesting. The button cell on the side here, I could just make out the word UASA. So UASA Corporation of Japan made these batteries. Of course, they're well known for various jigs in the machinist world. Not sure if I had the record button pressed, but basically I put this all back together. I tried putting the AC adapter on it. It wouldn't turn on. I tried the reset procedure of holding the 2 buttons down. It still wouldn't turn on. So then I began to wonder whether or not battery has to be present for this to work. See, it says here, talks about if the battery is allowed to completely discharge, a system reset must be performed. This is accomplished by pressing the on and clear keys simultaneously after recharging. Okay, so that makes me think the battery's got to be charged or have a charge. Under battery charger AC adapter, it talks about how it's powered by a nickel cadmium battery. Says operation for up to 8 hours from a fully charged. B indicator will appear on display when the indicator requires recharging. Recharging is accomplished using the battery charger / AC adapter for a period of approximately 16 hours with the instrument turned off. To recharge, remove the round plug from the top of the indicator and insert the charger AC adapter plug. The indicator will operate while charging, but the recharge time will will be several times longer. So that is what made me think that you could run this off the AC adapter with a dead battery. But it could be that the battery can't be completely discharged and dead. So I'm still not convinced that this might not all be still due to the fact that I now have the battery completely removed and that the battery is bad. So when I checked before, I was able to check and see that when I plugged in the AC adapter that there was voltage right here at the connector coming onto the board, but there was no voltage present between the negative on the adapter and the positive terminal on the battery pack. Well, I now see that apparently the positive terminal of the battery pack is actually down this end. It's down the opposite end where I expected it to be. I just assumed incorrectly that this was the positive terminal for the battery pack because it was such close proximity to where the power is coming onto the board here. And it turns out it's actually these two pins that are tied together as the positive. So no wonder why I wasn't measuring anything on the battery pack when it was trying to charge. So just for the heck of it, let's see if there's anything going on in the battery pack at all. The battery pack has 0 volts present on it. And I did, as you recall, you may recall, I had that, I tried charging that overnight. Well, probably 12 hours, not the full 18, but there should be something on there. Should be some residual voltage. All right, so we've got the voltage coming onto the board there. We got 0.2 volts coming into the battery. Let's see if we come. Oh, see, 10.5 across. So I can't use this ground to test that battery charge. Oh, no, there we go. Now there's 10.3, 10.5. Interesting. Okay. Makes me think the charging circuit's working now. I could have sworn there was 0 there a second ago. Maybe there's one of these ICs might actually be a controller for the charge circuit. And maybe it had to see a load. Maybe just putting the meter on there did something to wake it up. I don't know. All right. I'm bolstered by this somewhat positive indication of, pardon the pun, of something going on here in the circuit. I'm going to take a shot. I'm going to identify a battery to replace this one and put a new battery in this thing and see what happens. I could probably source a battery like this off of something like DigiKey and, probably wouldn't be too expensive. It's worth a shot because this thing, I mean, the AC adapter might sell for a few bucks on eBay. But the rest of it's going to be garbage, I figure, if I can't do anything with it. Let's see if I can't avoid slicing my fingers open. So, like I said, the only identification on this outer plastic sheathing is this number 108, which I'll Google that later. I put 108 battery pack and something. Look at that. Wow. You can see the corrosion on the inside here. Those are some funky looking cells in there. So it looks like what they do is they have little pieces of metal that they fold in half. They tack solder them to each side of the button pack to the button cell. Or these little seats that these sit in. I can't really tell. Pull on it maybe. Yeah. Don't really care. The main thing I needed to know about this battery pack is the fact that it's 1, 2, 3, 4 cells. Regular batteries are generally 1.5 volts per cell. Rechargeable batteries, NiCads like these, usually run around 1.2. So if we multiply, looks like it's about a 5 volt battery pack. Sometimes you can even get the number right off of the cell. So this is the positive end right here, the big plus. We already knew that, but there's no numbers, just UASA. So the part number for this battery is probably on the back side of it. This on the negative end, I'm looking at the back of the battery here. Made in Japan. I already knew that. What are your secrets? There's no number on there. How do you like them apples? I wonder how the heck they make this thing. This almost looks like it's spot welded to the next battery. But I mean, how the heck do they do that? Oh, I see what they do. This is a little metal pan right here. This is a little metal pan. So they must spot weld this metal pan onto this battery. And then the next battery inserts into that metal pan, gets crimped in. There's little crimps right there. Little tiny little. So you see those two little dots right in the center there? Those are actually spots where this little metal piece right here. So this little part right here that I got my thumb on is not actually part of the battery. It's actually a little metal cup. So what they do is they have, they'll have a cell, then they'll put this metal cup right here, and they'll spot weld that metal cup onto the battery, and then they'll insert the next battery into it. Actually looks like this metal ring right here is also maybe part of a case to hold the battery. The battery appears to maybe be this just inside here. So the part number for the battery is probably underneath this metal cap right here. Yeah, I should have just realized that was the positive end, which I already saw here. So unless this is a metal cover. Oh, I see it. It's just under there. This little metal cover is kind of obscuring it. So we got a 51 FT on this battery right here. All right, so it's been about a week since I started messing with this indicator, and what I was able to find out was the UASA battery that was in here apparently has been discontinued. I don't even know if UASA is still in the battery business, and it doesn't really matter because the type of battery I was able to determine, and turns out the company Varta, V-A-R-T-A, a major manufacturer of batteries, they make a battery that's almost a direct replacement for this battery. It's actually, I think, an improvement. So by using that information, I was able to determine how to search for the battery, and once I did that, that allowed me to find a even cheaper alternative. So what I ended up getting was this this battery here called an XL battery off of I believe I got this off of eBay, or it might have been Amazon, I don't even remember. But anyways, at first I thought this was going to be really hard to find. But then I narrowed in on, first, there's a battery almost identical to this that has 3 cells. And I think it's a 3.6 volt. I don't remember exactly. But anyways, that particular battery is quite a bit more popular than the 4-cell one here. Oh, I'm sorry, this is a 3-cell. My mistake. Apparently this type of battery is fairly popular in GPSs. So that's where it tends to be used a lot more. Oh, well, that's just wonderful, Steve. You put the battery on the wrong damn side of the board. How the hell am I going to use that connector with this in the way? Oh, man. So I forgot to hit the record button, but you didn't really need to see me fix that mess. What I did was I desoldered and cleaned up those holes, resoldered, cleaned up the pins on the battery again, resoldered the battery in the correct position, and then before installing that board with the battery, while I had access to it, I did my best to attempt to clean that glass scale. It looks to me like there might have been a little bit of debris or something on there. It could have been from the corroded battery material that was in there or whatnot. And then to clean it, I have this anti-static circuit refrigerant, which is basically it leaves no residue. So when I spray this on, this, because of the cooling effect, causes frost or condensation to instantly appear on the glass. And then I used a Q-tip. I prefer to use a lint-free wipe if I had one, but I don't. To very carefully just get any of that debris that was sitting on the glass surface off of there. Then I don't have a can of dust off, which is air in a can for blowing off optics and things like that. But if you take the can of freeze spray like this, if you invert the can and you spray it for a second, it will stop spraying the liquid, and it will just spray the air, propellant air that's in the can, pressurized air. So in a pinch. Then what I did was I measured the voltage across the battery. It was about 3.1 volts. So pretty much dead battery, which is what I would expect, because, who knows how long. They probably don't ship these with a full charge, and who knows how long this has been sitting on a shelf somewhere in a Chinese factory and coming across the ocean or whatever. So, but the good news is I then measured the battery voltage as after plugging in the adapter, and within a few seconds the voltage started coming up and it was increasing. So the battery appears to be charging. So far so good. So I'm confident that this replacement battery is going to work. The question is that the only issue that was wrong with this thing? We still don't know. The verdict's still out on that. I'm going to let this charge for a while. Just for the heck of it, I'll try and turn it on, but I doubt it's going to do anything. And it's still not turning on, but I'm not going to make any assumptions at this point. If I come back hours from now and I still can't get it to turn on, then I will render the verdict that this in fact has some other type of catastrophic failure, and all of my time and efforts and the cost of the battery are basically wasted at this point. But for right now, let's leave this be. We'll go do something else. Hey guys, it's only been about an hour, maybe even less, since I put this on the charger. Before I went back upstairs and had my lunch, I decided I just wanted to, for the heck of it, check this out. So I tried turning it on, and still nothing happened. In the instructions it says if the battery needs to be recharged, that you can plug it in and you can use it on the charger. It'll run off of the AC power, but it'll just take longer for the battery to charge. My theory was the reason why it wouldn't work before was because that battery was so bad. It also says that if the battery is allowed to completely discharge, you have to go through a system reset. So when I came back in here just now, I tried turning it on and tried holding the button down. Nothing happened. So then I decided, just for the heck of it, to do the system reset, which entails holding down the clear and the on buttons. And look what happened when I released it. Did you see that? All these lines came up across, and then it went dark again. I think it just reset, which I wasn't able to do before. So now, let's try and turn it on. All right, so it turns on, but it shuts right back off. So definitely an improvement over what we were seeing before. I'm wondering whether or not we need to just let this battery charge even longer. I'm not getting zeros, and nothing's happening when I'm moving this. So I'm going to be cautiously optimistic on this and just leave it alone and let it charge more. All right, it's been a few hours now. Let's see. Well, that's something different. You see, now it still won't stay on. Wow. So I thought I was losing my mind before when I noticed that there were only 3 cells present on that battery pack that I ordered. And lo and behold, this is what I ordered off of Amazon. I did order a Varta -4 V80H 3-pin 4.8 volt pack. Okay? And what they sent me was this, which doesn't say Varta anywhere on it. And to make matters worse, there's no part number on here, but the cell that was inside this battery, inside this box, was clearly a 3-cell battery pack. And at 1.2 volts, a 3-cell is going to give you 3.6 volts. So, no wonder why I'm possibly having a big problem here. I've got a 3.6 volt battery pack in this thing. This uses more than likely 5 volt logic because it's 4.8 volt for the battery pack. So I wish I had just trusted my instinct that my memory was correct and that I did order a four cell pack. Then I could have just said, oh, this is the wrong thing they sent me. Now the problem is, of course, that money's wasted because I installed it, even though it's completely the wrong thing. Well, I'll try Amazon anyways and see what they say, but I'm pretty sure I'm out of luck there. But now it looks like we get another delay because now we got to wait for another battery pack. Well, guys, after installing the battery, I only had to let it charge for not very long, actually, and I'm able to run it off of the adapter in like 15 minutes. So probably I was going to say probably you won't be able to run off of battery power, but it is actually already running off of battery power. I'm going to continue to charge it. So it's kind of an interesting indicator. I'm going to see if I can reposition the camera to make sure that we're getting a really good look at this thing. So first things first, the clear button does what you would expect the clear button to do. It zeroes it. And then you've got this mode switch here. So right now, I believe it's in absolute mode, meaning that pretty much as I actuate it, it's going to change. Let's well, that button is recessed. So you need something. There we go. Look at those decimal places, huh? How's that, guys? Look at that. 0.00030. All right. So it's interesting. As I push up, that changes to a plus sign, showing what direction it's going in. And as I release, it changes back to a... well, when it gets back to the origin, it goes to the negative sign. So if I hit the mode switch again, now it lights up, it says max. What'll happen is it will show me the maximum deflection I go to. So in other words, if I go up here, all right, that's 10 thousandths. Now watch when I release, it stays at 10 because 0.10055 was the max deflection during that particular run. If I go back up and I'm pushing up, once I get past that, that's the new max value. Consequently, hit the mode switch again, we have a minimum value. So if I preload this and I zero it, kind of hard to do this. I should really have this on a stand with gauge blocks. But you see, it actually will show me the largest minimum deflection. And then if I hit that again, I get the R, which I don't know what that does because that doesn't make a change at all. Oh, wait a minute. No. If I go all the way up to the max, it does. But this right here, this mode is just plain old-fashioned, going to work like a regular indicator. So this is pretty cool. There's a plus minus. I'm not sure what that does, and I can read through the instructions to learn all about that. But so it's kind of a neat thing. So I hope you guys enjoyed this video. Basically, ended up preparing this by simply sourcing and replacing the nickel cadmium battery pack that was in there. If you are not currently a subscriber, I would request that you consider subscribing to my channel. You never know what I'm going to get into next. And if you like this video, please take a moment and hit the like button. Take care.